all about how we can summarize data numerically now. So chapter 2 we just got done and we showed it visually with graphs and charts and stuff, but now we're going to do it numerically. So this is actually where the number crunching starts. So if you can, pull out your graphing calculator, okay? You are going to want to get one ASAP. If you don't have one, try to download an app for now. Rent one from around the corner at the Resource Center. Because after 3.1, some of the stuff we don't do by hand. We need those graphing calculators, all right? So 3.1 is all about measures of central tendency. What does central mean? The center or middle, right? The center or middle. So 3.1 is all about measuring the middle. Honestly, I feel like all of you guys have heard the terms that we're going to talk about today. You just might not know the notation that this book uses. How many of you guys have heard of mean, median, mode? A lot of you, okay? That is how we measure the middle, okay? So all three of those are measures of central tendency. So the math part's not going to be new to you guys. It's going to be the notation part that we want to make sure we feel comfortable with, all right? So 2 quick definitions that are just reminders. We've already seen these definitions. A parameter is a descriptive way to measure a population. Remember the P's go together? And a statistic is a descriptive way to measure a sample. Why are they reiterating that? Because in chapter 3, this is where we notice that. We might do the exact same math. How do you find the mean? It's the average. Add them all up and divide by how many you have. You're doing that for whether it's a sample or a population. But if it's for a sample, that mean is called a statistic. But if it's a population, that means called a parameter. Exact same number, exact same way you computed it, but the symbol and the name will be different, okay? So that's what we're starting off with. This is like the scary stuff. A handful of you guys took calculus before, right? Okay, so you've seen this crazy sigma before. If you haven't taken calculus, maybe you've been to a frat party, right? SIGAPs or whatever it may be. This is the Greek letter sigma. It means sum of all. Sum means add. What are we adding all? We're adding these little x with sub i's. These x sub i's are just a generic way to show individual data. So these are the individual data. All right, and then we'll see how good you guys are. I know this is something that we were introduced to like the first week in class. What does little n always stand for? Sample size, you got it. So right when I asked you how do you find a mean or how do you find an average, right? You said sum all of your values and divide by the size of your sample. So that's just a concise formula to show you what you've been doing all along, okay? Notice over here it's the exact same thing. What's the only difference is capital N. What's capital N stand for? Population size. So what do you want to take away from this? Do you need to memorize this formula? No, you already know how to do the math. What you want to take away from it are the 2 notations. If you see X bar, so I don't know if you highlight or circle that, that is sample mean, okay? So anytime they ask for the sample mean or if they say find X bar, they're asking you to find the sample mean. And then this, guys, you pronounce it mu, like a little kitty, mew. Any cat fans? Yes, okay, I love cats, sorry. Mu is going to be your symbol for the population mean. How I write him, he's basically a U with a long tail on the left. So like I'll write just a long tail on the left and go like that, okay? What you're going to notice is that stats, I'm going to go back up here, okay? Stats are always Roman letters, which is our alphabet. So notice over here for stats, for the sample mean, they used an X. We know X. That's from our alphabet, right? Anytime we're talking about parameters for population, they always use the Greek letters. So notice here for the population mean, they have a Greek letter mu. Okay? So kind of keep that in mind. If there was for some reason a matching quiz, you should only match Greek letters with population items and our Roman letters, our alphabet, with sample. Okay? So real quickly, guys, I don't really even feel like we have to do a whole lot of coverage of this. We have 2 sample sets, but before I get there, I'm just going to make this little note. If rounding is not told to you, you usually round the mean to 1 more decimal place than the raw data. So if the raw data has 1 decimal place, you would round to 2 decimal places. So notice here they don't tell us what to round to. They just say find the mean of the 2 data sets, assume that they're populations, okay? They don't have any decimals. So when we find our mean, we're going to round to 1 decimal place because that's 1 decimal place more than what our data has. All right, so what do I want you to show me on the test? Do you have to show me this crazy formula? No. Realize one, I'm going to give you all the formulas. So you don't have to memorize them anyway. You just want to know what they mean. But if you know to add them all up and divide by how many you have, show me what you get when you add them all up and show me what you're dividing by, okay? So for the population, I would have this, mu equals, and then I would put the total right here, okay? So what do you guys get when you add up those data points? 43, okay? And this is when I'm like just throwing it in my calculator. I'm not going to try to do it in my head at all. So you sum all these, so that's 43. So that's the sum, right? And then what am I going to divide by? 9. Why 9? Because there's 1, 2, 3, 4, 5, 6, 7, 8, 9 values there, right? You throw that in your calculator, 43 divided by 9, what do you guys get? 4.7. So on this, whenever you do it, I always like write as many as I can. Is it 4.7 repeating? Is that what it ends up being? So have you guys seen the repeating bar before? Like that? So I always like at first write as accurate or specific as I can. So like if I can do the repeating bar, great. If I can put a handful of decimals, awesome. And then off to the side, I actually write my final answer. What are all those 7s going to change that very first 7 to? An 8. So our answer is actually 4.8. And let's write units because they're going to have a story problem with it, okay? And so it's going to be 4.8 something. Not including Brittany and I, but maybe this is the hours that you sleep at night, right? So on average, this class sleeps 4.8 hours, okay? So it would have a unit there, but there's no story problem for this. I just want to point that out because my math lab always puts those units there, and you guys never need to think about it, but on a worksheet or on a test, I want you to remember to do that. Okay, real quickly, guys, guess what? B is the exact same thing. So what we're going to do is we're going to sum them. So you put them in your calculator. Beep or bop or beep. What do you guys get when you sum those?
52.
What was it, 52? Does that sound okay, those that are punching away? So again, you sum them to get that total number, and then you divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does that look all right? And notice that one lands perfectly on 1 decimal place, all right? So my answer, I would say, is 5.2 units, whatever this is standing for. Nothing new, right? What you want to take away from the means are the 2 symbols. X bar for sample, mu for population, all right? You know how to find averages. So mean is just another way to say find the average. All right, the next thing is median. How would you describe the median to someone?
The middle.
The middle. It's basically the middle number. The median, you notice, will just have a capital M for either set. So sample or population, it doesn't matter. And it's literally the value that is in the middle of your data set. So the key thing that we kind of forget to do, make sure you put it in order, okay? Does it really matter whether you do ascending or descending? No, but later on we're going to do some where you have to put it in ascending. So you might as well get in the practice. Always just order from low to high. That way you'll always have it in the correct order. So these next things are like, why do we have to have like steps in finding the middle? Because sometimes the middle is not so easy to find, okay? So the first thing they ask you to do is arrange it from small to large. Determine in your sample size, how many things do you have? So if your sample size is even, do you guys agree that you don't have a value that's technically right in the middle? Right? If it's even, if you have 10 things, you split them 5 and 5. The middle would be between those 2 5 sets. So what they do is they say average those 2 things. How do you find the middle? You take your data value and split it into 2. That data value plus one more are the two middle things. And so these are not the medians. Please realize these are not the medians. These are the locations of the median. Location of median. And again, I am a stats teacher, and I read these, and I'm like, what is it saying? It's not until we actually do it that hopefully it will click in, all right? If it's odd, what they say to do is just add 1 to your sample size and divide by 2. That will get you to the middle, okay? So again, this is the location. It's not the actual median. Notice the keyword position, right? So if you flip the page to the top of page 2, guys, you'll see 2 data sets. One have an even number amount and one has an odd. When they're small like this, do you really need to use these formulas? No, but when I give you a data set that has a lot, it might come in handy, okay? So first, let's arrange it from small to low, or small to low, that doesn't make sense. Small to large. I kind of cross them off as I do them. Does that look okay? Is that what you guys got? And then so that was step 1. Step 2 says determine what your sample size is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is 9. So a lot of you guys can look at 9 and know the 5th digit is the middle, right? So you just count over 5, 1, 2, 3, 4, 5, and that 5th position would be your median, okay? So this is if you just know. Or do some of you guys do this? Pair it. You pair it. Do. He's the middle. So M equals 4 units, whatever this is standing for. So again, maybe this is the hours slept at night. The median is 4 hours there, okay? Why did I write n equals 9 over here? Because I wanted to show you if for some reason you needed to use those formulas, because again, the formulas will be given to you. I'm going to flip it back to the formulas, okay? N was 9, so how do you find the middle? 9 plus 1 is 10. 10 divided by 2 is 5, the 5th position. So notice we counted over 1, 2, 3, 4, 5. Do you usually need to do it on smaller sets? No, but what if I said you have 83 data values, what's the median? You do 83 plus 1 is 84, and then 84 divided by 2 is 42. The 42nd position would be your median, okay? So those formulas are not necessary. They're just kind of helpful if you have a larger data set. All right, B. Again, let's order it from least to greatest. So what do we have? 1, 2, 2. Is it 4, 4? 7, 7? 8, 9, 9. Does that look right, guys? Let's count our n. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equals 10. So whenever you have an even amount, they say just literally divide it in 2. And those 2 values that border the middle, we're going to average them, all right? So what's half of 10? 5. So we're going to count over 5. 1, 2, 3, 4, 5. And this is where we're going to divide it, okay? This is where the median is going to be. So what do we have to do? We have to average the number 4 and 7. Well, how do you average 2 numbers? Add them up and divide by 2. So our median, guys, is going to be 4 plus 7 all over 2, or 11 over 2, or do you guys get 5.5 there? And I'll move my big hand so you can write it all down. But again, if you had a larger data set, maybe, I don't know, 48, just remember the middle would be 24 and 25. And so you would measure those 2 values and average them. Are there any questions there? Capital M for median, make sure you have units involved. Otherwise, you're just finding the middle. Okay? All right. Before we move on to the mode, we have to talk about this idea of resistant, because means are not resistant, medians are. So we kind of want to talk about it. So it says, a numerical summary of data is said to be resistant if extreme values, very large or very small relative to the data, do not affect the value substantially. Okay? So medians are resistant. And I want to try to my darnest to make it make sense to you why they are and why means aren't. What's it mean to resist? Like I have a 2-year-old and she resists a lot. What's that mean? She's not budging. She goes like this. She already turns her back, crosses her arms at me, and looks at me like that. 2, okay? So she's very resistant. She's not budging. She's not moving. That's the same thing with this mathematical term. So me, I make a lot of mistakes. So say on this first data set on A, I said, crap, guys, that wasn't supposed to be a 9. That was supposed to be a 99. Does that affect your median at all? No. Why not? Because I would list all the data values exactly the same, but instead of 9, what would I put there? A 99. But what's still our median? 4, right? But switch it up. If it's our mean, I say, crap, guys, that's supposed to be a 99. Would that affect my mean? Yes, because I had to add all those numbers to get 43. So instead of adding 9, I should have added 99, which I would have gotten a lot larger sum, which would give me a lot larger mean. And so my mean would be pulled drastically. What would that be? Extra 90. So like, what's 133 divided by 9? 14.8. So my average is supposed to be measuring the middle, right? And I got 14.8. Is 14.8 a good number to describe the rest of those numbers? No. So that large value of 99 really threw it off, so it wasn't resistant. Here, it didn't change a darn thing, okay? And that's true for low numbers. If that was supposed to be a -2, it wouldn't have changed anything, right? So medians are always resistant, and they just want to talk about that with you. All right, why do we need to know this? Because skewness, the reason why data values get skewed from chapter 2 that we learned is because there is a really extremely high or a really extremely low value that's trying to pull it away. So if you're skewed left or skewed right, always use the median. If you're skewed left or you're skewed right, that means there's a really low value or there's a really high value trying to pull you one way or the other. So the median is the best measure of the middle. If you're symmetric, use the mean. If you're symmetric, use the mean, okay? So this would be a mean to measure the middle, but here we would use median to measure the middle, and here we would use median to measure the middle. Because if it's skewed left, that means that's a really low value pulling my mean way lower than it should. And if they're skewed right, it means there's a really high value like that 99 that's pulling my mean way off to the right than it should. So the median's a better way to measure it, okay? Notice where the mode is in every single place. We haven't talked about the mode, so that's why, like, again, I don't write my own book, so I shouldn't rip on books. But they talk about this section before they even talk about mode. But mode means most. It's the most often, so it's always the highest point. So look at the graph. High, high, high. That's always where your mode is, okay? So let's talk about it. Mode means most. I feel bad for mode. Why? Because mode has no symbol, okay? So I just labeled mode equals. There's no symbol to represent him. He's the variable that occurs the most frequent, okay? Not just because he occurs more than once. He occurs more than any other value, all right? Do you have to put them in order? No, sometimes it just helps. But notice here, I think this is kind of a catch-22. And those that follow me, you'll see what I'm talking about. Those that don't, it's not a big deal. It says, we can have no mode if no data values occur more than once. So if every single value is unique and does not occur, there's no mode. We can also have multiple modes if there's more than one data value that occurs the most. For example, a data set might have 2 numbers that occur the same amount, so that would be called bimodal. If there's 3 numbers, it's called trimodal. If there's more, it's called multimodal. So what's the catch-22? To me, if no numbers repeat, they all occur the most, right? They all occur one time, so they all should be the modes based on that definition. So kind of just keep in mind, you have to occur more than once in order to be a mode, and you have to be the most. So let's look at this. We have 3 occurs twice, right? 7 occurs twice. Okay, they're both kind of in the running. But what do you notice about 4? 1, 2, 3. So our mode, you would just write mode equals 4 units, whatever those units are representing. All right? That is just I don't know if that's a word, unimodal. It's only one mode. Go ahead and flip it to the top of page 3. Let's see what's happening here. I know some of you guys are working ahead and you probably don't even need me. 2 occurs 1, 2 times. 8 only occurs once, so he's not in the running. 9 occurs 2 times. 7 only occurs once. 4 and 6. So 4 is twice as well, right? So what is our modes? Our modes are 2, 4, and 9 because they all occur twice. You guys see that? And we'll put units behind there. So this would be called, I would call it trimodal. They just call it multimodal in your book if it's past 2. So say you had all these showing up 2 times, but then 1 showed up 3 times, 1 would be the only mode. Okay, he has to occur the most. So even if they occur more often, then that's it.